In this episode of Tech Effect, how robots are covering new ground in space exploration. A robot-human partnership that's lifting the weight off our shoulders. And machines that mimic the natural world. The idea of building intelligent automaton stretches far back into human history. Early science fiction promised human-like mechanical creatures. When a real robot debuted at the 1939 New York World's Fair, he was an object of awe and excitement.
And so, ladies and gentlemen, with a great deal of pride and pleasure, I present to you Electro, the Westinghouse Moto Man. Electro, come here. And here he comes, ladies and gentlemen, walking up to greet you under his own power. You see, all I need to do is to speak into this phone, and Electro does exactly what I tell him to do. Sometimes. But I don't see why I'm telling Electro's story when he's perfectly able to tell his own. So let's listen and see what Electro has to say to us today. All right, Electro, will you tell your story, please?
Who? Me?
Yes, you.
Okay, Toots.
Robots of the 21st century come with a little less attitude, but far more functionality. Electro's skills were limited to being able to smoke a cigarette, blow up balloons, and move his hands and legs. Boston Dynamics' Atlas robot demonstrates almost human-like agility. As well as humans, robotic engineers take their inspiration from the natural world. The flick-flack spider, found on the edge of the Sahara Desert, can propel itself into the air by somersaulting and rolling. Festo's BionicWheelBot is designed to walk and roll like this spider. To start rolling, the BionicWheelBot bends 3 legs, each on the left and right of its body, to make a wheel. 2 legs extend to push the rolled-up spider off the ground and continuously push it forward. This prevents the BionicWheelBot from stopping and ensures it can move itself forward even on rough terrain. Like its natural role model, the artificial spider rolls faster than it walks. The robot can even climb uphill. Through developing robots like this, bionics experts are creating devices that can traverse difficult terrain. Festo's BionicFlyingFox is based on the only mammal in the world that can fly. This ultra-lightweight winged robot is able to move semi-autonomously in defined airspace. With a wingspan of 228 centimeters and a body length of 87 centimeters, the artificial flying fox weighs just 580 grams. Its wing kinematics mimic the natural flying fox, including an elastic membrane which continues from the wings down to the feet. Like the real thing, the bionic flying fox can control and fold its wings together individually. The flying fox is tracked by 2 infrared cameras that feed images to a master computer. This controls the flight and feeds algorithms to the flying robot, enabling it to learn from every flight and constantly improve its performance. Festo's Bionic Swift is an aerial robot that uses the agile swallow as its inspiration. To make maneuvers as true to life as possible, the wings of the robotic bird are modeled on the plumage of real birds. Individual membranes are made of an ultralight, flexible, but very robust foam. Like real swallows, the Bionic Swift travels in a flock, with 5 machines able to move in a coordinated and autonomous way, interacting with a radio-based GPS. Intelligent networking of flight objects contributes to technology that could be used in the network factory of the future. Geolocation data could streamline processes and anticipate bottlenecks. And flying robots could transport goods around warehouses. Not content with creating artificial creatures on the ground and in the air, Festo is also working on underwater robots. The bionic Finwave is able to swim collision-free through a pipe system made of acrylic glass, thanks to ultrasound sensors, in the same way dolphins and pilot whales find their way through dark and murky waters. With an undulating fin motion, the bionic Finwave swims confidently through the pipe, using 5 ultrasound sensors to constantly measure the distances to the walls and ensure it's propelling itself in the right direction. While Festo's impressive robot range is still in development, Boston Dynamics has brought its robots to the marketplace. After years of testing, Spot is now available for sale, attracting buyers who need a robot that can cover rugged and dangerous terrain that wheeled robots can't manage. Spot has 360-degree vision and obstacle avoidance. It can be driven remotely or taught routes and actions to perform autonomous missions. The American-based company plans to commercialize some of its other prototypes as well. Big Dog was developed for the American Department of Defense as a possible pack mule for soldiers in terrain too tough for wheeled vehicles. To help it navigate difficult paths, it has a variety of sensors, including a laser gyroscope and a stereo vision system. Little Dog has 4 legs, each powered by 3 electric motors. The legs have a large range of motion, and the robot is strong enough to climb. Little Dog's sensors measure joint angles, motor currents, body orientation, and foot-ground contact. One of Boston Dynamics' earlier robots was Wildcat, which paved the way for its current technology. It was the fastest quadruped robot on Earth, able to reach speeds of 32 kilometers an hour while maneuvering and keeping its balance. Wildcat's main purpose was to push the boundaries of robot flexibility and speed. Petman is a tethered Boston Dynamics robot developed to test chemical protection suits. It's the first human-like robot that moves like a real person. And robots that move like people are an aim of South Korea's Naver Corporation. Their prototype, Ambidex robotic arm, can be controlled by a 5G network from anywhere in the world. It has cable-driven mechanisms that makes interactions with humans safer and has potential applications in manufacturing and defense. At just 2.3 kilograms, Ambidex weighs less than a human's arm. It can be operated at a speed of 5 meters per second and can carry up to 3 kilograms. The robot arms can support high-speed, wireless, real-time control from remote locations, using 5G brainless robot control technology. The arm is controlled over a 5G wireless link using complex sensors and the latest 5G data management. Advanced robotics technology has the potential to transform people's lives, making the human-robot partnership one of the keys to a better tomorrow. Still to come, covering new ground, robots in space. "86 million kilometers from Earth, the Mars Space Laboratory begins its descent to the Red Planet. It's heading for a landing target in the Aeolis Palus region of Gale Crater. Hurtling through the Martian atmosphere at a speed of 5.6 kilometers a second, the spacecraft's instruments are monitoring the atmospheric conditions and performance of its heat shield. As the heaviest craft ever to attempt a Mars landing, the laboratory experiences the highest heat flux and shear stress ever faced by a vehicle's heat shields. It pinpoints its target, a 3.5 billion-year-old crater, and carries out the most accurate Martian landing of any spacecraft. On board the laboratory is the Curiosity rover, a car-sized autonomous robot, specially designed to navigate the planet's rugged and rocky terrain. Curiosity's mission is to investigate the Martian climate and geology, search for evidence of microbial life, and provide data that can be used to plan a human expedition to Mars. Crammed with scientific instruments, the 899-kilogram rover is powered by a generator that produces electricity from the decay of radioactive isotopes. This should keep it alive for at least 14 years. Robots like Curiosity are helping scientists access places humans can't reach. But for a successful mission to Mars, the robots first need to be tested on Earth in the right conditions. The rocky deserts of Utah in the United States can be a good substitute for the Martian landscape. Scientists from the Robotics Innovation Center of the German Research Center for Artificial Intelligence test their robotic systems in Utah by simulating a complete mission sequence. Mission control is in Bremen, Germany, more than 8,000 kilometers away. The successful tests give scientists important insights into the robustness and mobility of their systems. Another robot being developed for space exploration is the SpaceBok, a jumping space robot that flies like a spacecraft. Built by a Swiss student team, SpaceBok follows the example of astronauts who found themselves hopping rather than walking on the moon due to its low gravity. The team is slowly increasing the height of the robot's repetitive jumps and have reached up to 1.3 meters in simulated lunar conditions so far. The prototype has performed so well that they even used it to play a live-action game of Pong, the classic video game. The SpaceBok is just one of the innovative products tested at the European Space Agency's Planetary Robotics Laboratory. The lab supports research, development, and testing of the two main robot types used in planetary robotics: rover platforms and sample manipulation systems. It evaluates planetary probes before they even reach the drawing board stage, saving time and money. There are many exciting innovations in the pipeline, from transformer robots that can convert their wheels to legs, to a robot trash collector that will use its forelegs to grab space debris from orbit. Scientists are even studying the possibility of soft robots, with the ability to move sinuously across rocky surfaces. One European Space Agency experiment focuses on an intuitive human-robot interface, designed to solve even complex manipulation tasks. The Subfis Justin project is testing the possibilities of managing significant communication lags while commanding a robot to carry out dexterous work. German astronaut and geophysicist Alexander Gerst is excited by its potential.
Subfis Justin is a fantastic experiment because it takes human-robotic interaction up to a new level. We have a test here of a robotic system that is controlled by an astronaut in a spacecraft, in a space station in this case, and the robot is actually located on the surface of a planet. Well, in this case, it's a test planet, it's Earth, right? Later on, this could be Mars, it could be the Moon. All right, I'm coming a bit closer to the SBU-1. The scenario is as we are the crew on orbit around Mars, and we send a rover down there as the first scout to see how the conditions are like, whether it's safe, what the atmospheric parameters are. And so we command that rover, but the difference to how rovers were commanded in the past is that this rover actually knows to navigate by himself. So I don't have to tell him every millimeter to move in which direction or what to do exactly, but I just give him high-level commands like check out this solar panel or pick up this rock, and he will actually do that.
Still to come, a robot-human partnership that's lifting the weight off our shoulders. It's not just space where it's useful to have a robot to handle hazardous conditions. Animal is the world's first autonomous offshore robot. Equipped with a customized sensor head, the four-legged robot autonomously performs various inspection tasks on an offshore converter platform in the North Sea. The 320 kilovolt converter station has a 960 megawatts power transmission capacity, making it the world's most powerful installation of its kind. It can power more than 1 million households with clean energy. Animal helps to reduce the risk of disruptions and ensures the security of the electricity supply. The robot monitors machine operations, transmits sensory readings, and detects thermal hotspots and oil or water leakages. At any time, Animal can be remotely operated from an onshore control center to provide real-time information through the robot's onboard visual and thermal cameras, microphones, and gas detection sensors. Biotics, the company that created Animal, has the motto, "Let robots go anywhere." The four-legged robot has also undertaken an inspection of Zurich's sewerage canals, a labyrinth of drains and tunnels beneath the Swiss financial center. NASA's Puffer robot traverses difficult terrain using just 2 wheels. Flattened like cards, a number of microbots can be stored in a larger, 4-wheeled robot and deployed when it's necessary to explore smaller spaces. Scientists plan to try them in dangerous places like volcanoes. As well as saving us from danger, robots are partnering with humans to take over the grunt work in some industries. At a Barcelona plant operated by the automotive giant SEAT, 8 autonomous robots can transport more than 2,000 parts per day. The robots communicate with their surroundings and regulate traffic by controlling the traffic lights. Known as an automotive guided vehicle, or AGV, these robots use the latest technologies in navigation recognition, 4G connection, and induction electric battery charging. But robots are just one part of the intelligent workplace. Samsung is using 5G connectivity to create dynamic networks that will transform the factories of the future. In a 5G-enabled smart factory, real-time communication among millions of sensors, devices, and systems will have the capacity to improve environmental safety and quality control. In Samsung's own factories, advanced technologies are improving daily operations, ranging from storage to manufacturing, transport, packaging, and shipment. This is possible by combining 5G networks with artificial intelligence, robotics, the Internet of Things, and mixed reality. When these technologies work together, they allow more intensive monitoring of products and manufacturing equipment, reducing the likelihood of defects. Robots can do the heavy lifting, working non-stop and at a steady speed that can't be matched by human endurance.
from human to robot, back to human again. The combination of a human with a robot overcomes the many limitations of a human being.
Automotive manufacturers have been swift to perceive the benefits of robotic strength. Hyundai has developed a new vest exoskeleton, or VEX, a wearable robot created to assist workers who spend long hours working in overhead environments. VEX enhances productivity and reduces fatigue by imitating the movement of human joints to boost load support and mobility. The wearable vest functions by combining multiple pivot points with multi-link muscular assistance, eliminating the need for a battery. At 2.5 kilograms, VEX weighs 40% less than competing products and is worn like a backpack. The concept of an exoskeleton comes from the tough external shells of animals, such as beetles and crabs, where a strong covering protects the body underneath. Some of the earliest human-designed exoskeletons were created for the military to increase soldiers' endurance. Today, tests are underway to see if it's possible to incorporate robotic technology into items such as clothing and footwear. At Nissan, line workers now wear a robotic exoskeleton that supports their legs, shoulders, and back, reducing the stresses normally placed on their bodies by up to 60%.
We are here in Nissan Barcelona, where we assemble the parts of the cars. There are some workstations where the operator needs to work with hands overhead position, so this can make a little bit of stress of their muscles, and we are in search of some solutions to improve this condition.
In Spain, we have the Catalan Automotive Cluster, which is composed by a group of companies working together to improve the current conditions of the industry. They had a project to introduce the exoskeletons in the automotive industry, and we saw the chance to gather with them to collaborate. The exoskeletons help us to reduce the muscular efforts during certain operations. This results in less fatigue for the operator.
The first time I put on the exoskeleton, it was a strange sensation, but as I carried on working, it felt more and more practical to have my arms supported. There are various models, but I found one that was the most practical and, in the end, the most comfortable to work with.
After the trials, we find that with the use of the device, we can reduce up to 60% of muscular effort. In Nissan, we have a lot of new technologies that are used in our cars, so we want to also use new technologies for our employees. We have been trying these new technologies with a very good results.
As the partnership between robots and humans gathers pace, there's no limit to what can be achieved. Matching human ingenuity with the speed, power, and strength of machines will transform our lives in ways we can only imagine. In this episode of Tech Effect, how automated aviation could shape how we travel. New horizons for airliner design, now and into the future. First, uplifting mobility solutions. In 1903, when the Wright brothers flew their flyer at Kitty Hawk, North Carolina, they could never have imagined the ways powered flight would transform the world. More than a century later, the Kitty Hawk Aeronautical Company named in honor of the Wright brothers, is working on its own transformative technology. Kitty Hawk is one of the pioneers of all-electric vertical takeoff and landing aircraft, also known as eVTOL. Its latest concept is Heaviside, a single passenger plane with a range of 160 kilometers from just one electric charge. Heaviside is 100 times quieter than a helicopter, flying at a sound level of just 35 decibels, a level that is barely discernible to the human ear. With the ability to take off or land in a 100 square meter area that does not need to be paved, the aircraft has many potential applications. As cities become more congested, planners are looking at options such as flying taxis to get people off the roads. Urban aviation has the potential to put everyone in the pilot's seat.
My only dream from my childhood, I remember, was when I could fly, and it was such an amazing feeling that from that point on I just felt it has to be real.
Kitty Hawk's Flyer prototype has a control interface so simple that would-be pilots only need an hour's tuition before they can fly it.
Very few of us have a privilege of flying, but now, in less than an hour, you can learn how to fly.
I think everybody on Earth, they dream of flying, especially as a kid. You look up in the sky and you see a bird, or you even have dreams at night where you can just start flying. And now with Flyer, we're gonna be able to walk out to that dock today, get inside of it, and start flying. I feel completely prepared to get into Flyer and take off. We did the training yesterday, so we did the simulator training, and then we did the strap down where we turned on the vehicle and kind of revved it up, and it was tied down to the ground. I've felt the power of Flyer, and now to take the straps off and just start flying, it's a kid's dream come true. It's a complete breakthrough in aviation, to have something so simple, so intuitive that someone like me can just get in and enjoy the freedom and the joy of flight.
That was incredible. It's like part of your body.
Yes. When it comes to urban mobility solutions, the biggest dream of all is the flying car. Having the option to switch between driving and flying has been part of our vision for the future since flight began. Aeromobile 5.0 is a Slovakian concept 4-seat flying car designed for door-to-door flying. When traffic is light, you can stay on the road. If it looks like you'll hit congestion, the onboard computer recognizes the route and sends you to a heliport, where you can launch into flight mode. Powered by an electric motor, the Aeromobile has wings that pivot backwards when the vehicle is in its driving configuration. It has a range of 700 kilometers and is designed to be flown in any weather conditions. If it's able to secure the necessary certifications and permits, the company plans to launch the 5.0 by 2030. So it might not be long before we see cars taking to the skies. Japanese company SkyDrive has a clear vision for how it sees flying cars fitting into our lives.
この先渋滞中、飛行モードを推奨します。飛行可能エリアに入りました。
東京のオフィスまで。
かしこまりました。候補が2カ所あります。
外部ノイズをキャンセル。
かしこまりました。旋回してください。
了解。
SkyDrive sees a future where flying cars are as common as land-based ones.
9時に間に合う？
5分前に到着予定です。
ギリギリだな。
SkyDrive is a Japanese tech startup that's designing another electric flying car. Japan is getting serious about being at the forefront of the flying car revolution. The country has set up a special council that brings commercial operators together with government regulators to work out the practical details of getting flying cars safely airborne. SkyDrive came from a group known as Cartivator, an association of engineers from established brands like Toyota, who worked on speculative designs in their spare time. Now Toyota is a SkyDrive investor, along with NEC and Fujitsu, and a number of Toyota executives have been brought on board as advisors. Thanks to the car company's support, SkyDrive is able to use the 10,000 square meter development base at Toyota City. That includes an indoor flight test facility, one of the largest in Japan. The company is also developing cargo drones with the ability to transport heavy goods and equipment to hard-to-reach places. The global market for flying cars is expected to be worth billions of dollars by 2040. SkyDrive is determined to be one of the industry's main players, and a recent successful manned flight shows it's on the right flight path. Rideshare company Uber is expanding its horizons from the ground to the air. To overcome the gridlock of city traffic, Uber wants its passengers to consider an electric vertical takeoff and landing aircraft as a transport option. By taking advantage of space above the skyscrapers, urban aircraft will reduce congestion and make cities feel more open and accessible. Uber pictures aerial ride-sharing as a way of providing a flight option across a city's busiest areas. The plan is to have customers check in at custom-built skyports located strategically around the city and hitch a ride in an autonomous aerial vehicle which would swiftly take them to the closest skyport of their destination. If necessary, the passenger would transfer to ground-based transport for the final stage of their journey. Uber's Elevate network includes partnerships with 8 of the world's most innovative aircraft manufacturers. They are each developing concepts for eVTOL aircraft built specifically for ride-sharing. Uber Air would be powered by Elevate Cloud Services, a suite of software with the ability to manage dense operations of unmanned low-altitude air traffic. The company is currently using its Uber Eats urban drone delivery service to test its air traffic management system. The top names in architecture, design and engineering are currently working on skyport concepts. It's a big task, as the buildings need to be capable of handling up to 1,000 landings an hour. Boeing is one of Uber's aircraft partners, and its latest autonomous passenger air vehicle has been undergoing rigorous testing. A check of the electric aircraft's autonomous functions and ground control systems saw it pass with flying colours, so it might not be long before it arrives at a skyport near you. Still to come, smart cockpits for smart pilots. The skies of the future will be teeming with drones and autonomous air taxis, as well as airliners. Aircraft manufacturer Airbus is developing an air traffic management system that aims to support the rise in unmanned aerial vehicles needing clear flight paths. The purpose of Airbus UTM, or Unmanned Traffic Management, is to identify the most efficient airspace structures for new technologies. The huge projected increase in small aerial vehicles traveling around cities makes it essential to create a system that enables all autonomous aircraft to communicate their positions with each other, as well as with an overarching traffic control.
first step to achieving clarity in what are the standards and regulations for autonomous systems is that we need to get everybody together and sharing and open and on the same page. We need collaboration across the industry because this problem is bigger than any one company.
The entire aviation industry focuses around taking small steps first, which is very important. By getting small applications in place, we make valuable learnings, we gain a lot of information, we gain feedback, we gain economic information and viability, and all of that will boil together to produce an even better next iteration as we scale up the services, have more aircraft, and have them do more complicated things.
So it's a really exciting time for the industry. It's really just kicking off. We've done a lot of the R&D, and right now is when real UTM services are starting to be implemented.
The system we put in place today and over the next few years will be the system that's in place for decades to come, and it will affect the next generation of people using the air traffic control system.
As part of its digital transformation, Airbus has invested in touchscreen options for pilots of its A350 aircraft. When combined with the electronic flight bag, they provide easily accessible displays that bring up vital information with just the touch of a finger.
Welcome in the cockpit of the A350 XWE, which happens to be the best cockpit in the sky. The core of this cockpit is made by 6 large, identical displays, which have been developed by Thales. These screens allow to display the right information for the pilot to fly, navigate, communicate, manage the system, as well as with the EFB to manage the mission. This cockpit is the one of our MSN 373 to be delivered to China Eastern. For each pilot, the electronic flight bag is made of an airline laptop racked in a docking station next to the pilot seat. The display can be performed on the cockpit outer screens or something which is unique to the A350 when a pilot selected OIS on center on the lower center display. The control of the electronic flight bag can be obtained via the tablet integrated keyboard or via the trackball controlling a cursor via the Keyboard Cursor Control Unit, or KCCU. The new development made by our supplier, Thales, makes their screens capable to be touch screens. This is a new way allowing interactivity with the electronic flight bag applications, and for the time being only on the EFB applications.
But perhaps this technology is just a stepping stone to something even more advanced. Airbus has spent the past 2 years successfully testing autonomous taxi, takeoff and landing of a commercial airliner, a world first in aviation. This has been achieved through fully automatic vision-based flight tests using onboard image recognition technology. More than 500 test flights have been flown, with 450 of them dedicated to gathering raw data to support and fine-tune algorithms. A series of 6 flights conducted 5 takeoffs and landings per run to test the aircraft's autonomous flight capabilities. In Wyoming, USA, scientists are working to improve weather forecasts.
Mike from Monarch. We're testing a GNSS-RO sensor on board the Atmospheric Research Laboratory from the University of Wyoming. Back there, Brian and Paul from Night Crew Labs, just making sure that everything works.
Our flight plan is we basically go up as high as we can on the aircraft. Then we maintain altitude, continue a straight and level flight for about 280 nautical miles. We make a U-turn and we come back. The aircraft is collecting multiple channels of atmospheric data, and we're looking at humidity data. We have a vertical LiDAR profiler. We have a cloud camera that's taking pictures of water vapor particles as well as icing droplets.
The sensor payload tested on the mission has the potential to improve the choices we make around weather-related events by adding truth data to forecast models and increasing accuracy.
So how's flying a plane?
That was such a unique experience. That was one of the coolest things I've ever done. God.
One of the things that's so amazing about this trip is that my whole life I've wanted to work in aviation and I've wanted to work on flying laboratories. The view is beautiful outside, but you have a lot of work to do, and you're getting in the console, making sure that all the parameters are coming back correctly, and it's really a thrill. Like I really enjoy it. And yes, we have a lot of flying hours to do. Hopefully I enjoy it by the end, but it's just gorgeous scenery and amazing science. So I am really happy.
Still to come, aviation looks to new horizons. What will flying be like in the future? How will automation and customized options change our traveling experience? Manufacturers such as Airbus are investigating ways new technologies can be integrated into existing design. One possibility is cabins that automatically reconfigure to accommodate the number of people on a flight. Instead of overhead bins, passengers place their hand luggage in a separate storage area to be retrieved at the push of a button. The ecological self-cleaning seats will morph to suit the shape of the person sitting in them, while a floating touchscreen provides instant access to entertainment and assistance. The engineers who designed this fantasy flight envisage an aircraft that's ultra-long with slim wings, semi-embedded engines, a U-shaped tail, and a lightweight, intelligent body. This design will improve the flight's eco-efficiency, resulting in lower fuel burn, a significant cut in emissions, less noise, and greater comfort. Those planning for the future believe that passengers will expect seamless access to a wide range of technology and applications. Flexibility will be key, so we can enjoy many different experiences on board. Hologram pop-ups take you to whatever social scene you want to experience, from conferencing to virtual meetups. The airliner of the future will not just be a mode of transportation. It will include wellness options that make travel energizing and exciting. Walls that become transparent at the touch of a button, making you feel as if you're floating above the clouds. Holographic projections of virtual decors allowing travelers to transform their private cabin into an office, bedroom, or Zen garden. The aircraft's bionic structure mimics the efficiency of bird bone, which is optimized to provide strength where needed. This allows for an intelligent cabin wall membrane, which controls air temperature and the level of transparency. The cabin's integrated neural network creates an intelligent interface between passenger and plane, and can identify and respond to passenger needs. This includes the opportunity to experience vitamin and antioxidant-enriched air, mood lighting, aromatherapy, and acupuncture treatments, all while taking in the panoramic view. By offering different experiences within each zone, airlines would be able to achieve price differentials and give more people access to the benefits of air travel with minimal environmental impact. While some of these concepts may seem beyond the realm of possibility, the fast pace of technological development means they might just be closer than you think. With autonomous airliners on the horizon and short-hop electric sky taxis waiting in the wings, it won't be long before our skies and our modes of transportation look very different. One option for our aviation future is hypersonic airliners, a concept Boeing has been working on for some time. It could see us crossing an ocean like the Atlantic in under 2 hours.
It obviously looks quite a bit different than what you would consider a normal airplane to be. One of the key differences is what it's made out of. When you're traveling that fast, friction causes the surface to become very, very hot, over 1,000 degrees, sometimes well over 1,000 degrees, depending on how fast you're going. So you can't make it out of aluminum. You have to make it out of more exotic materials. For example, at about 1,000 degrees, you can use titanium. Beyond that, you can use nickel-based alloys, something called Inconel, up to about 1,500 degrees. Beyond that, you have to go to ceramic materials.
At this stage, hypersonic passenger flight is more conceptual than realistic. Airbus sees potential in electric-powered airliners as it searches for ways to fulfill its mission to increase environmental efficiencies. EFAN-X is a complex hybrid electric flight demonstrator that has had one of its 4 engines replaced with a 2-megawatt electric motor. In partnership with engine manufacturer Rolls-Royce, the project tested the possibilities and limitations of a serial hybrid electric propulsion system in a demonstrator aircraft, the first of its kind in the world. More than 30 projects are currently working on hybrid electric power for airliners, and it's hoped the technology could become commercially available in just over a decade, leading to lower emissions and reduced fuel bills. But aviation in the future is not just about repurposing today's technology. Some options might see us reaching even higher than sky.
The very first thing that we did as a company when we started out was we talked to our customers about their expectations for what they wanted when they went to space. And it was those expectations around the rocket ride, the weightlessness, the view of the Earth from space, and the reception of their astronaut wings upon the conclusion of the journey that were the key drivers behind our entire design process.
So, where will you fly tomorrow? In this episode of Tech Effect, a new mission to the Moon sets the stage for the first crewed flight to Mars. The technology behind the latest generation of spacesuits. A look at the rockets that will take us further than ever before. But first, space tourism offers new views of our planet. Virgin Galactic is moving closer to its goal of providing suborbital space flights for tourists. The Richard Branson-founded company has released a conceptualization of what the cabin of its first Spaceship Two vehicle, VSS Unity, will look like. Space enthusiasts can download a free augmented reality mobile app to experience it for themselves. The cabin has been created to integrate seamlessly with every other aspect of the Virgin Galactic astronaut journey, as well as being a design centerpiece in its own right. Each passenger is issued an individually sized reclining seat for G-force management and float zone volume. Automated mood lighting harmonizes with each flight phase. Personal seatback screens connect astronauts to live flight data, while the cabin architecture supports effortless movement in weightlessness. Soft surfaces and elements become intuitive hand and footholds. And most importantly, there are 12 cabin windows through which astronauts can gaze down at Earth. The windows have soft, extended edges, allowing astronauts to perfectly position themselves for 360 degrees of awe-inspiring views. Chief Astronaut Instructor Beth Moses has had the opportunity to trial this unique experience.
My name is Beth Moses, and I'm the Chief Astronaut Instructor and a flown astronaut at Virgin Galactic. I was the first person to fly in the customer cabin of Spaceship Two as an engineer and an instructor testing the cabin. And that flight showed that the cabin was ready for human occupancy. I flew in a prototype cabin with research payloads, tested a lot of things. It tested a few ways to get in and out of the seat. It tested ways to improve the seat interfaces. It tested translation aids, handling aids, how you move about the cabin. Very fundamentally, it looked at how the cabin moves about you when you are floating and weightless. What aspects of the experience stand out, perhaps in ways that we didn't anticipate before a human could go calibrate that. So now I've rolled that all into training and into the cabin design so that it is perfectly tuned, elegant, easy, safe, wonderful. It was already freaking remarkable, and now it's even more so for all of our future customers. So the moment where we strapped in and the hatch was closed and the wheels started to roll sticks with me as a moment of sort of personal gravitas, like I am about to do the most important job of my life, and I am going to do it well. The rocket motor is not exceptionally loud. You are under 3G, you are rocketing into space. It is the rocket ride of your life. And then the rocket motor cut off. You can see the Earth outside all the windows. It is super, super bright, very high definition. It just engulfed me. Space is deep, deep, deep black, and it looks endless. And probably the next standout moment, I did the first half of my test, and then I purposely joined the pilots near the cockpit for apogee. And that's probably the standout moment of my life. Floating, free, in the ship, and the ship came to a stop above Earth, and it felt endless. The cabin interior supports savoring the view of Earth from space in every way possible. It both facilitates your movement about the cabin, so you can get to any window or next to any person that you'd like to, while simultaneously not distracting you from the view that you're looking at. The cabin interior will be successful when the space flight and the view of Earth from space is the star of the show, and the cabin is almost an invisible but perfect supporting act.
But it's not cheap to take a ride on the VSS Unity. For $250,000, you get a 90-minute flight that takes you high enough to experience weightlessness and see the Earth from space. By surpassing an altitude of 80 kilometers, Virgin Galactic space tourists will also receive official astronaut status. Amazon's Jeff Bezos is another entrepreneur who has his sights set on space. The billionaire founded commercial spaceflight company Blue Origin in 2000 with the aim of making access to space cheaper and more reliable through reusable launch vehicles. Blue Origin envisages a future where millions of people live and work in space, tapping its unlimited resources and energy. Its rockets transport payloads for organizations such as NASA, who have used the launches to further research for their upcoming moon mission. At a cost of just $8,000 a payload, the company has even flown experiments for school students. A second-grade class in Indiana was able to demonstrate that fireflies can light up in zero gravity. Blue Origin's New Glenn orbital vehicle will take tourists into space, where they will experience weightlessness and new views of our planet, just like the Virgin Galactic astronauts. The cost is expected to be about the same. Blue Origin was recently awarded a NASA contract to develop an integrated human landing system as part of the Artemis program to return humans to the moon. The third big player in the commercial space industry is SpaceX, the company founded by Tesla's Elon Musk in 2002. Its original aim was to reduce the cost of space transportation to enable colonization of Mars. The company has since become the first private operator to successfully launch, orbit, and recover a spacecraft, and the first to send a spacecraft to the International Space Station. SpaceX's latest innovation is an interplanetary transport system known as Starship 4 to be used for crewed missions to Mars. Expected to be completed by the early 2020s, Starship will be the biggest rocket ever made. The system will comprise a fully reusable, two-stage-to-orbit, super heavy-lift launch vehicle, which requires considerable testing due to its innovative design. The heavy launch vehicle is just required for the initial launch, as only Earth has the deep gravity well that requires such a powerful booster rocket. Once the vehicles escape Earth's gravitational force, Super Heavy detaches from Starship, leaving the lighter spacecraft in parking orbit. The booster then flies itself back to Earth, landing on its original launch mount, ready to be prepared for its next expedition. Still to come, style and function feature in NASA's new spacesuits. When you put a human being in a spacesuit, sometimes the impossible is possible. Since 1965, NASA has conducted hundreds of EVAs, short for extravehicular activity.
So when I think of EVA, I think of the symbolism of a fellow human being existing for even just a short period of time, alone and separated from nearly everything else. And I think of that symbol of that single person representing our species and representing our voyage of exploration.
Before exploration can take place, before a human being can step outside the spacecraft, another mission must be accomplished: the creation of the spacesuit. Throughout the history of EVA, NASA has sought to build the best spacesuit and tools to match the job required for the mission. For its suit engineers, this means designing, testing, and redesigning to get it right. During the Gemini program, designers were faced with the challenge to create the first US spacesuits. Suits that would allow the astronauts to work outside the spacecraft in low Earth orbit. Building on that experience, new suits were developed for the Apollo missions. This time, astronauts needed to walk on the moon while carrying their own life support on their backs. With planetary surface exploration as the objective, the suit had to bend and move to allow tool use and protect the human. During the shuttle years, NASA redefined what could be done with the EVA suits and tools. The same shuttle spacesuit is on the space station today. It allows astronauts to maintain and repair their home in space. But what about future missions? What kind of suit will we need for walking on an interplanetary surface, floating in microgravity, or both? NASA is already investigating the next generation of spacesuits, working on a range of prototypes to prepare astronauts for the journeys ahead. The Z2 is one of those prototypes. Its sleek design looks different from any other spacesuit NASA previously built.
We were able to take some artistic license on this prototype spacesuit and have some fun with it and engage folks out around the country for what they would like to see in a spacesuit. We work with Philadelphia University to do the initial layouts of the suit, and then we have some in-house fashion designers that also helped build our spacesuits, and they were able to bring their experiences to it and evolve that cover layer to make it even better than what we started.
The Z2 isn't just fashion-forward on the outside. It's also technologically advanced on the inside.
To be a planetary spacesuit, some of the special features on the Z2 are boots specifically designed for walking and for keeping your foot integrated into the boot well, like a good hiking boot. It also has a lot of lower torso mobility that allows you to walk naturally so that you can go uphill, downhill, into craters, pick up a rock, as a geologist would want to do on a planetary surface.
Like any prototype, NASA hopes to learn a lot from the Z2 as it continues to improve and develop spacesuits.
Prototypes are really important for spacesuit development because you can only do so much in the modeling and analysis world. You really don't know how well the suit works until you integrate it with a person. You get the feedback that a person can give you. You have them walk around, you have them try different tasks. That's how we really know that we've done a good job designing a spacesuit.
Another suit in the works is the Prototype Exploration Suit, or PXS. This suit can be used for EVAs in microgravity, or it can be further modified for walking on planets. As with all future spacesuits, NASA is wanting to see better mobility, better visibility, and better control and communication.
So one of my main responsibilities on this spacesuit is the suit control assembly, and that's the box that sits right here on the front of the suit. And it allows the crew member to control their life support components, such as their cooling and their pressure, and it also controls a lot of the electronics, such as the radio and the volume, and they can see some of the data that's coming back and forth from the suit computer to that display. So one of the great things about this job is that after designing the box, I'm able to get into the suit, since it's one of the smaller sizes, and we can actually see what the limitations are with my own hands and eyes, and not just hear that secondhand from another test subject that would be looking at the same data. And then to take that back and then to go build the next prototype and incorporate the changes that need to be made so that it works better the next time.
It's not just spacesuits that are key to a successful EVA. Astronaut training is also vital, especially when the mission is difficult. European Space Agency astronaut Luca Parmitano recently undertook a spacewalk at the International Space Station to repair the alpha-magnetic spectrometer. The AMS-02 is a particle physics experiment mounted to the outside of the space station. 3 of its 4 cooling pumps needed replacing.
It's a combination of things that makes this EVA so challenging. You have certainly an access problem. AMS is in a remote area without handles or locations to hold on to because it was not made to be repaired EVA.
0 and liftoff. AMS was carried to the space station on the final flight of Space Shuttle Endeavour and installed using the shuttle's robotic arm. As the most sophisticated particle detector ever sent into space, AMS allows scientists to find dark matter. To date, it has detected over 100 billion cosmic particles, greatly enhancing our knowledge of the universe. When the decision was made to extend the instrument's life, a series of specialized tools and novel spacewalk techniques had to be developed. At the Johnson Space Center in Houston, experienced spacewalker Luca Parmitano played a key role in this process.
I've been lucky enough to have been part of the development team from the beginning, initially just as a consultant and then actually getting closer to the team in using me as a test subject for some of the tools. They've been incredibly receptive to our suggestions and responding to our ideas. It's been exciting.
Working inside a spacesuit in microgravity poses many challenges. Luca and his NASA colleague Andrew Morgan trained on specialized equipment to recreate working conditions in orbit, such as the Argos system, which effectively removes gravitational force to create a simulated EVA environment. Numerous underwater sessions in NASA's Neutral Buoyancy Lab gave Luca and Andrew a working knowledge of the space station's exterior, rehearsing fully suited operations on a mock-up of AMS.
We're going to perform what could be considered open heart surgery on this amazing experiment. We're going to cut tubes and then fuse them with other tubes that we're going to bring from Earth and install a completely new pump to help the refrigeration work, keeping the magnet cold so that the alpha magnetic spectrometer can work.
Drawing on their extensive training and experience, Luca and Andrew have since successfully undertaken a challenging series of spacewalks to restore the alpha magnetic spectrometer. Their mission included cutting and splicing 8 cooling tubes, connecting them to the new system, and reconnecting power and data cables. It was the first time that astronauts had cut and reconnected cooling lines in orbit. They also had to identify and repair a leaky feeder tube. As the astronauts worked on their tasks, they were closely watched by Mission Control in Houston. When undertaking strenuous work, they used more oxygen, so their spacesuits were carefully monitored to see how they were performing. At 5 hours and 2 minutes into their third spacewalk, Luca broke the record for accumulated time outside the space station by a European astronaut. It was the 227th spacewalk for the International Space Station. Thanks to their efforts, the AMS has now been fully restored, allowing it to explore our universe for many more years to come. Still to come, Mission to Mars. "50 years after putting the first man on the moon, NASA is planning to return.
We have a bold vision to go, and we do so knowing that space exploration has improved the human condition in countless ways. And it is the partnerships over the last 50 years that have ensured a steady progress in the science, technology, exploration, and discovery for the benefit of all. With America's new directive to put humans on the moon in 2024, NASA is leading the development of exploration capabilities, and we are building a coalition of nations that can help us get to the moon quickly and sustainably together.
With the help of partners such as other space agencies and private space companies, NASA is working to an ambitious timeline. Next-generation space technology is being used to build advanced spacecraft to take crew to the moon and ultimately to Mars.
Accelerating the timeline means a lot more focus, means a lot more dedication to the task, and we're up for it.
One of the key mission features is the development of the Gateway, a moon-orbiting platform that will serve as a waypoint for human capsules.
Gateway is a great step towards the future of the human being. It's a great pleasure to collaborate with NASA in that endeavor.
Gateway can be moved between orbits and will balance between the Earth and Moon's gravity. But the technology is so advanced, it requires the best scientific minds from all over the world to contribute.
NASA is one of our major cooperation partners in space exploration.
By going together to the moon, forward to the moon, whatever the time span is, the faster the better. That's something I really like.
Scientists hope the lessons learned will enable them to develop a successful mission to Mars. Between 1968 and 1972, NASA launched 9 human missions to the moon, 6 of which successfully touched down, allowing men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of both creating a long-term human presence on the moon and preparing for a human mission to Mars. To reach the moon, astronauts will fly in Orion, a spacecraft built in 3 parts. The crew module can house up to 4 astronauts who will live and work throughout the flight. The service module contains the life support systems for the crew and its own engine and fuel reserves. And there's a launch abort system with engines capable of pulling the crew module to safety at launch, should anything go wrong. The world's most powerful rocket, when fully fueled, Orion weighs over 6 million pounds. 5.2 million of that is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, projecting the crew upwards. 2 minutes after ignition, the rocket boosters are spent and released. At 8 minutes, the 4th stage is depleted and separated. Approaching the moon, we see a difference between the Artemis and Apollo missions. Artemis will use a revolutionary approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners, including Gateway, the dedicated lunar station in orbit around the moon. Here at this station, the astronauts can pre-stage a robust lunar lander and establish a strong communications relay. When that's complete, selected astronauts transfer to the lander and descend to the surface. They use the same lander to leave the moon and head back to the Gateway, where they return to Orion, firing their engines once to break out of the halo orbit, and once again to sling the spacecraft around the moon. They head back to Earth. Nearing the end of this journey, the service module is released and the crew module is oriented heat shield first. The deployed parachutes decelerating the craft to just 20 miles per hour for splashdown.
10, 9, 8.
The recent launch of the Mars 2020 Perseverance rover highlights the next chapter of Artemis, the mission to Mars.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Oh man. That's the noise.
It might not be long before we join robots on Mars and experience the next frontier of human endeavor.
Did you feel it inside?
So, where will you fly tomorrow?